Every time I come there, I'm tempted to climb up in the roof.
I still don't know what's up there.
You don't know? Okay.
No.
If I look at that, I think, hey, it'd be fun to climb.
Welcome. How you doing? Hey. I'm Mike. Nice to meet you. We have here, we know where the Sharpie is. Oh, we got name tags for you. And then there's pizza and drinks just over there if you want anything.
Thank you.
I think we can work all for 5 more minutes, then we can get it started.
Hey, so Mike,
Yeah.
are you recording the GoTo meeting too?
Yeah. Yeah, I just started recording, so we'll post that as well.
Let me just ask, how many here work with Docker and Vagrant before, or use it all the time? Okay, then I guess we should talk a little about it.
Okay. Yeah, we could.
Yeah, I'll do some general comments on what things are. Hopefully it's helpful and not just annoying. But yeah, let me know if you have any questions. That can explain anything more. Search technology or anything really.
Maybe have Drew chime in a little as well.
Sure. And Drew, you can hear us, right?
Yeah.
Cool.
I can hear you.
Sweet. That's Drew in the box.
And we'll show you pictures as well, so just so you know who we are. I'm guessing everybody uses Jenkins, or have used it at some point or the other. Okay.
Anyone comes in, we'll just shuffle them in. Thanks everyone for attending. This is great. I see so many new faces for this, so I'm really excited for you guys to give this presentation. It's clearly hitting a lot of pain points for people, so look forward to it. And if you guys have any questions, we will post the recorded GoToMeeting on the Meetup page, and we'll also post the recording as well. But realistically, the GoToMeeting audio will be a lot better because we'll probably get a discussion in there as well. Funny enough, you guys.
Okay. Well, thanks for joining us, everyone. I'm David Weiser. I work at G Digital in our DevOps group. We support pretty much the entire company in terms of getting the build infrastructure and.
David, you're swinging them, yeah.
I'll tell us how. Yeah, well, okay. Let's try this again. that good?
Mm-hmm.
So this being California, I figured we'd do something California-ish, right? Let's try a group confession. Okay, so how many of you voted for Trump? No. Okay. How many of you are or have been a developer at some point in your lives? If you wrote code without unit tests for at least a year, please raise your hand. Okay, 5 years? 10 years? Okay, just a couple of. So, right, it's amazing, right, how things have changed. Everybody's writing unit tests, things are good, and we're writing all kinds of automation tests. Obviously, to run all these tests, we invented this notion of continuous integration, and we've been build the tools such as Jenkins to allow us to run that. So let me ask a question: how many of you have been an admin for a Jenkins server? Okay, great. If you have maintained the Jenkins server manually, please come back.
Wow.
So this is the reason I'm here, is that up until a while ago, my experience has been the following. When I worked for certain kinds of companies like Google or Plumtree, we always built our CI servers from scratch, and they were always sort of modern. Everything was completely automated. Everything was basically pipeline code. Right? But in my consulting practice and recently, I have been using Jenkins, and basically we've been just kind of setting up a little Jenkins server, configuring it manually, and using it that way. And what happened to me probably about a year ago is that we used the same approach on a project that exploded, and suddenly we found ourselves with hundreds of Jenkins jobs. And so when we had to change one thing, suddenly it was like war room situation. Gather the whole team, divvy up the Jenkins jobs, and let's go and fix it, right? And of course, there's things you can do. There's tricks you can grab the Jenkins XML and you can fix it there. But that is very, very dangerous in some ways. And the other problem is with Jenkins is obviously just setting up the Jenkins master itself. So today we're going to see how to avoid that kind of nightmarish scenario. And to do that, I have brought experts with me. So I would like to introduce from Liatrio, Ravi Kalaga, and Dan Stein, and on the phone we have Drew Holt. So I will turn this over to Ravi to get us going.
Sure.
So Ravi, how much I'm going to get the...
I think I have a loud voice. You just want to leave it there so that the team goes in.
I put the camera.
Oh, okay.
Sorry. We'll do the makeup later.
Hey guys, Ravi Kalaga. We're from a company called Liatrio. We're a small boutique DevOps consulting firm. We specialize in building software delivery pipelines for large enterprises. So our focus is on going into large organizations which struggle with software delivery. Our philosophy stems from the fact that software development has become very easy. Software engineering is still hard, don't get me wrong. Software development has become very easy in large enterprises, but delivering software to the field, to the customers, has become really hard because of internal silos, because of bureaucracies, because of handoffs, because of monolithic release processes, because of people who don't want to communicate with each other, whatever it is. Software delivery has become really hard. So we believe in the philosophy that you have to look at, you have to reimagine the work that happens in large enterprises and really build software delivery pipelines so that those pipelines will help you to visualize how code goes from a developer laptop to production and how you put efficiencies across the board. So that's who we are, that's what we do. We really believe in the philosophies of DevOps and scalable agile. We don't practice it as a religion. It's more of how we take how to do the work is more important to us than what work you're doing, because once you get the how right, whether we are communicating across with each other, whether we are sharing information, whether we are really open, whether we hang out with each other, we like each other's company, then the how becomes simple and the how becomes good. I think what you work on becomes very enjoyable. That's some of our philosophies. And then we also believe in getting better one day at a time. No silver bullets, no chef puppet for everything, no investing in $1 million service virtualization tools. Can we just get better one day at a time? So building on those philosophies, we work with enterprises to build software delivery pipelines. I'll go to the next one. So you can read through it. I won't talk about all of that. I think the slide deck is going to be there. Who are we? Those are our faces. You probably don't have Drew. I'm a DevOps consultant. My job is to lead large clients through DevOps transformations. Ben is our engineer who does all of the magic. He builds software delivery pipelines. Drew is our infrastructure architect. And security architect. We have a small joke on him. He writes cookbooks for dinner. I mean, he really does. All he works on is building automated infrastructure pipelines. So that's Drew. That's what he does. So here's where I'm going to get into a little bit of spiel before we talk about getting into the demo. So, of course, we are simplifying this a lot. This is a meetup. If we were doing a technical architecture kind of a meetup, then we would go into a lot more details. But before we get into Jenkins and why Jenkins or how to set up Jenkins, talking about automated delivery pipelines becomes very critical. What we believe is that you have to make sure that code here is multiple things. It's just not UI code or services code. It's test scripts. It's infrastructure code. It's your security code. It's your network changes. Everything becomes code in a modern enterprise, and you need to build pipelines for that. And if you get into everything as a code and you want to start talking about configuration management, you want to talk about infrastructure automation, you want to version control all of it. And when you do, that helps you to trigger pipelines, a simplified pipeline like that. So you have developer laptops, you have Bitbucket, you have Nexus, which is your artifact repository, you have Jenkins, which is, I think, the core of all software delivery orchestration. You have your SonarQube, which gives you, your testing capabilities, and then you take code all the way to production. This picture is not representative for all of the pipelines that we have, but this was something simple. Only to give you a picture that Jenkins is just one small piece. The automation around Jenkins is one small piece. The focus should be around building automated delivery pipelines. Okay, we'll get into the demo in just a bit, but I just wanted to introduce. So what are we going to show you today? Most of you have used Jenkins. Most of you have probably known about it. Most of you have probably interacted with it. We'll try to keep it very simple for this meetup. We'll show you Jenkins 1.6, which is where 90% of the enterprises use. Very few people are on 2.0, and we'll talk about why and how sometime later. But Jenkins 1.6 on Vagrant. Most of you probably have heard of Vagrant. It's a developer's best friend. You can replicate everything that you want on your local. A Groovy DSL job creation that allows you to not have to create jobs manually. You can outsource it. So any of the administrators in the room, you can actually make your development teams set up all of your build jobs, deploy jobs, do your builds, do your deployments. You don't have to worry about doing any of it. And also see a small delivery pipeline where your build artifact goes to the artifact repository. So we'll talk about all of that. And then we'll also talk about Jenkins 2.0. The current version is 2.19, so we'll show you that. The UI is slightly better compared to the legacy Jenkins. But then we'll do that on Docker. And where the industry is going, it's all containers in the field. Now, whether you should use a container like Docker in a real production system is still up in the air, because it's really hard, and you have to think about a lot of variables before you actually put a container in the field. But that's where the industry is going. We'll talk about Jenkins file, which is something better than Groovy DSL, and then we'll talk about a small delivery pipeline. Before we start, questions? Any thoughts, concerns? This is not why we are here for. Yeah.
So we use CloudBees.
Yeah.
Enterprise edition for Jenkins. So where it fits? I don't know.
Yeah. So this is where you get into a philosophical conversation with us, right? So we believe Jenkins is open source. Most of you probably know the history of Jenkins. Hudson had a big divorce. Jenkins, Hudson, open source. We believe there is enough open source community out there that you don't actually need a reseller like CloudBees to use Jenkins. Where does CloudBees fit in? Just use what they give you and open service tickets for them, and they'll fix all your problems. But then also know that you're paying $100 for an agent, which could be really free, right? Where does it fit in? Doesn't really matter. They have a Jenkins, what do you call that? Jenkins image from CloudBees that you could use.
Yeah.
Similar, certain restrictions on the CloudBees side because you have to work with their image, but then it's pretty much the same.
Okay.
But if there is anything that we would like to ask you, if you have any influence in places where there's CloudBees, and not that we compete with them or anything, it's just that a tool like that. We are in California, as David said, we are the most vibrant software development ecosystem out there. We should push towards open source as much as possible. That's my 2 seconds speak on it. All right, I'll give it to Ben. Drew's on the call. He'll jump in if something comes up, but then we'll walk through the whole thing, and then you can ask us as many questions as you'd like.
Cool. Thanks, Robbie. So again, I'm Ben, DevOps engineer at Leatrio. My specialty is building out pipelines, mostly in Groovy. My favorite language right now. For building out pipelines in Jenkins, build, deployments, kicking off test suites, etc. That's not the page that I want. So we'll start out with Vagrant. I know a couple people raised their hands saying they know what Vagrant is. Just a quick overview of what Vagrant is. It's a manager for sort of like a development manager for VMs just for your machine. It's not something that you get to use in any type of environment outside of your computer. And what Vagrant allows, yeah, it's the wrong thing. There we go. No, Vagrant is a application that will manage virtual machines on your computer.
Okay.
So instead of spinning up VirtualBox yourself, downloading a disk image, and putting Ubuntu on a box, Vagrant does it for you. And does this in a file called a Vagrant file. It's declarative. I'm going to walk through that right now because that's a large part of development for Jenkins. So I do all my development first on my local machine. I don't try things out on our sandbox or production Jenkins. So you want to prove everything out locally because it could be catastrophic. You can use history, etc. So first part of Vagrant, the first thing you notice is config.vm.box. That's where you specify the base image. So that's going to be what your OS is. It might even have additional applications installed. You get this from like HashiCorp's Docker Central. So in this case, we like using CentOS 7 because it's the same thing as Red Hat 7. You can use Ubuntu, you can use whatever operating system you want as long as it's Linux. And then next, so ignore 5 through 7. There's a bug with this box, and I had to include these extra lines. And then 8 and 9 are forwarded ports. So this is a virtual machine running on your box. So there's a full OS on it. It has ports just like a computer. We need to link those up because we don't want to necessarily hit custom IP address on your machine. You want to hit localhost and treat it like it's on your local. So forward ports allow us to do that. So as you know, Jenkins runs on 8080 by default. So what we're going to do is we're specifying the guest 8080, and our host want to be, let's say, I throw it on 8000. So if I go localhost 8000 on my computer, it's going to essentially looking at port 8080 on the guest machine. And you can have multiple machines. You can have unlimited Vagrant boxes. You probably want to limit that depending on how much RAM and disk space you have, but you do have that option, which makes Vagrant very powerful. And then the next line is for SSH access. And then line 10 is sort of the most important part of this file. This is provisioning the box. So first step is getting that base box. So 10, so I'm specifying that I'm provisioning it with shell script. And that script is right here. So what's going on here is I'm installing Java. So just yum install, installing Git, installing Jenkins from Amir on Red Hat. So I'm installing Jenkins 1.6. Turning off firewall because I don't care about security on my local. Starting Jenkins, and then I'm making sure the firewall is off. It's a pain you're trying to hit a port and nothing is coming up. And then finally, I think that's the last. Oh, and then finally, for local development, Vagrant takes care of all the hardwiring. You can do sort of like a symlink for directory. It's really like mounting a volume to the Vagrant box that allows you to work on code on your local. You're not SSHing to a box and working in Vim. You can work in your IDE, and you can reference that directory and any files in that directory on the VM. Does that all make sense? So that way when I'm in Jenkins, I can specify that files that I'm working on in real time. I don't have to pull from Git to use Jenkins locally. You can just reference files on the disk as though they were written there. So real quick, I'm going to spin up a Vagrant box. I'm not going to build it. That would take about 20 minutes. So I'm just going to do Vagrant up. I'm going to make it a little bigger so we can see what's going on. So making sure everything's up to date. It's going to clear any forward ports, forward those ports, boot up the machine, wait for that to go.
Yeah, so one of the reasons why we didn't want to show you the whole downloading is it would just eat up our time. So
forever.
Just bake something, we just halted it, bringing it up.
There we go. All right. And while that's going, I'm going to cheat a little bit. I'm going to spin up Nexus, which is an artifact repository, just for storing jars, wars, zips.
Ben, hold on for a second. How many of you know artifact repositories? Okay, just a couple of seconds spiel on it, just so we're all on the same page. So one of the things that we see a lot in our clients that we work with is the not separating artifacts from your builds and your deployment jobs. What happens is over a period of time, once you start using CI a lot and once you get into automated pipelines, you want to make sure your code artifacts are secure for long term. Number one. Number two is security is becoming a big concern. I'm sure all of the places that you work with, security comes up all the time. How do you manage your third-party libraries, right? Which the source code that you download from the internet because you use it more and more. So having the ability to divorce where you do your builds from where your source code is, where you have your artifacts is a good practice in general. So that's why the pipeline that we're showing, instead of standing up another environment, what we wanted to show you was actually the process of pushing to an artifact repository, because that is as good as, going to an environment.
Cool. So Vagrant, it took about 30 seconds, going from machine off to machine on. So this is clean Jenkins. I did install a couple of plugins before it came, just because it would take too long to manually go through. But in this situation, I would go through, go to Manage Jenkins, install. So I'll highlight the plugins that I installed real quick. Main thing was installing Maven and Java just through the UI. And then the main one that we're going to look at is Job DSL plugin. And what this allows you to do is configuration as code. You can script out your jobs, all with Groovy DSL. Those who know what Groovy is, it's it's a scripting version of Java, runs the JVM. It's just-in-time compilation. So there's no compile step. You can just run Groovy scripts directly. But very similar Java syntax, just no semicolons essentially. And then some additional functions. So here is my job DSL. This is very simple. It's going to pull down a repo of specifying. Can you guys see that? It looks like color is not set, but specifying that's going to be a Maven job. So Jenkins runs a lot of Maven jobs. So they even have their own specified type of job called Maven job, where the build step is just going to be a Maven goal. So all we're going to do is pull down from Git and do a Maven deploy and skip tests because we don't want to run it for too long.
So make one comment. So for those of you who have, how many of you have messed with the Jenkins XML files for jobs? Anybody modified XML files manually? No? Okay. Yeah. So basically, yeah, great. So this thing, this job DSL actually is a generator. All it does is it generates the XML files, but it looks so much prettier, right? So it's not like it's executing that that script. Is that it uses the script as an input to a generator, generates the same XML file, so you can always go and look at the XML files later.
I had a little question in that script. What was the dskip? What were the goals about?
So that's just a Maven command, dskip tests. For this repo that we're building, it's testing a long time, and we don't want to sit here for 10 minutes while you paint dry.
So you just skip tests?
Yeah.
You won't do all the tests?
For this demo, we're going to skip all tests.
So let me talk about Pet Clinic, because I think we should talk about it.
Okay.
Have any of you heard of Pet Clinic? Okay. It's our favorite Java open source project. We use it for everything. Every time we have a tool that we want to demo, every time it's available on GitHub. It is a very nice Java project because it has everything that you want. It's got code that is written very well. It's got tests that are, you can run a lot of tests for it every time you do a bit. We are using that just to showcase you can run it to even an open source project. Number one. Number two is for this one, but just for this demo, if we start running the tests, which are as a part of the code repository,
Right.
it's going to take us another 15 minutes. So we just said, we don't want to run tests for now, just to show you how a job comes up, how a build happens. You can just remove that after the meetup. Maybe just let's remove that and we'll try to run it, and you can see all the tests running successfully as a part of the build.
Okay, now I get it. Why it's there.
Yeah. We're taking some shortcuts in the just for time. So I'm just going to grab this script. I'm going to create a new Jenkins job, our first Jenkins job. It's going to be a freestyle project because we're just going to call the job DSL step. So let's just call this say job creator. And it's going to have one build step called process job DSLs. I'm just going to use the provide DSL script. Normally, we're going to pull from Git, but let's pop this in here. And let's build it.
When we're doing that, does everybody know what DSL means? Okay.
Domain-specific language.
Yep.
Exactly.
Just making sure.
So what happens? So now we have two jobs. So this created the Pet Clinic build. And this is a simple script, but you could easily expand it. You could put, for loop around here, and you could make a many, and you can very quickly spin up hundreds of jobs. So in this build, it has everything that we specified. From Git, run the Maven goal, deploy tests. So let's build this. And that's much more pleasant than clicking around the GUI for each job. And you never have to do it again. Once you have that seed job and hook it up to Git and just push up DSL changes, you'll never have to actually click around Jenkins ever again. So while that's going,
Let's show an example of a lot, huge,
Yeah, so next while that's going, I'll show an example of one of our scripts. So I have this script gotten, a little big. So this is a 362-line groovy script that generates, I think, now 800 jobs. It has a config that goes along with it. I won't go deep into it at all, but just know it's the point where we're using classes. And it's a real software project managing these jobs. It's not a job for someone clicking around. It's for developers to actually do.
Yep.
And this is testable. So you can run. There's a jar that you can download. So you can run this against the jar and generate the actual job XML. You can add that if you want, or you can run tests to test the XML. It's become like software, like the actual project. So hopefully so that's finished. So our goal, right, is to deploy the Pet Clinic WAR to Nexus. So this job finished. The only thing that we've edited in this file, actually, I'll pull this up. And the POM file. Is everyone kind of familiar with Maven? So the only thing that we changed in Maven was we specified the distribution management. In this case, since we're using, there's better ways to do this, but our BeggarBox sees the host machine with the IP address of 10.0.2.2. So we just threw it in there for now. So that's how it looks for Nexus. And because Nexus is running in Docker, which I'll cover in a couple of minutes, it looks at localhost. It's Vagrant sees, or Jenkins sees Nexus as running on our actual machine, even though it's running in a container. I'll talk about that in a minute. So in here, we go to snapshot repository, and there it is. So if we go in this version, that WAR has been deployed right here. And that's all with no minimal clicking around, just using job DSL.
And just to expand on it, the 800 job file that we showed, the cool part is not that it can generate 800 jobs. The cool part is the operations teams no longer now need to do this work. When there is a development team that is trying to create a new project or they want to work on a new application, they can use this as a service. So now we're trying to change the conversation into, we no longer want the build, deployment, tools, platform, DevOps teams to do the work. We want them to build the pipelines and the automation. The development and the testing teams now can control their own destiny. They can spin up their own Jenkins instance, because when we talk about Docker, you can actually see how easy it is to spin up multiple Jenkins instances and actually bring up slaves. And now they can then create their own jobs. And they can do their own builds, they can do their deployments. That's, I think, the industry shift that's happening, where you're moving away from a team trying to do the work to being more builds and deployments as a service.
What is the Groovy aspect? The code you showed us, the C5 lines?
Yeah.
What does it do actually?
So
I'm not getting that.
it creates build jobs, creates deploy jobs, it creates smoke test jobs, and links them all together. So it reads a config file that you can specify, oh, my project is located here. I want to deploy to these environments after build. I want to deploy these environments later, not necessarily hooked up to the build. I want to add test coverage. And it's all just flags, or maybe a couple of lists.
So you run that one time and it creates all the jobs for you.
So I have it run automatically. So I have a pull SCM. So whenever anyone makes a change to master branch in that repo, it gets updated. And no one can push directly to master. It's locked down. You have to do it through a pull request. But anyone can do it. Anyone can pull down that repo, run it locally so you bigger it up, and they can run and see all those jobs generated in the local Jenkins, and make changes, test them out locally, push it up in a branch, do a pull request in a master, and then it gets integrated hopefully within the hour. Does that make sense, or is that too much?
That was a lot of information. But I was saying, so you kick that off, it creates a job, the thing that you showed us earlier.
The create job?
The job and then you build it, right?
Yeah, so you create that first job,
yeah,
which references the job DSL.
Okay, and you do that one time.
One time, and then, yeah, all the other jobs are dynamic. You can have it set, there's a setting, whether, if you like, let's say we removed that job name, if I change the name, you can have it delete the old job automatically. So you can do it dynamically. So you can have 700 jobs, and then tomorrow I'll have 20.
I see.
Yeah. So next up, I'm going to go to the future or the present, depending on how big your company is. So I'm going to do a beggar destroy. I am done with this box. I don't need anything on it. We can recreate it within a couple of minutes. You sure you want to destroy default VM? I do. It's been destroyed. So next up, we're Docker. So I'm going to spin up, so Docker. So just talk about Vagrant, spins up virtual machines on your box. So Docker, for those who don't know, it's an application container.
Drew, you want to help us out?
Sure. So Docker is a good example of application-level virtualization compared to having something like VirtualBox, where you have an entire OS file system and such like that. Docker just is run as a single process on your box. So it's very lightweight. You can do Docker container cascading, so Docker within Docker within Docker. And we're really excited to be working with it now.
So it's much lighter weight because it's not an additional OS. All it does is it brings the parts that it needs on top of your current OS. So instead of having a full installation of CentOS, it has like a couple of megabytes of information and then your actual application. So very lightweight. You can have a ton of Docker containers. You have very little process degradation by that. Versus virtual machines, there is definitely a hit performance-wise. So I'm going to spin up Docker. While that's going, that should take that long. I'm going to talk about a couple files. So we have the Docker file. This is the definition of the Docker container that Jenkins is going to run in. So sort of like Vagrant, like you said, it's cascading. So you specify a base box. We're going to start with an OpenJDK 8 box. So all this box has is Java 8, but it has everything it needs to run on top of your current OS. So this is just like having, CentOS with Java 8 installed. We're going to do a couple things. We're specifying ports, specifying a volume, so that way when we spin this down, we're not going to lose information on it. It is stored in a directory on our machine. And then some other requirements for Docker and
Talk about the plugins.
yeah, plugins. So this is the most important line, my favorite line. So before, I didn't show you guys, but normally when you spin up Docker or Jenkins, the first thing you do, you go to manage Jenkins and install a bunch of plugins, right? So what working with this with Jenkins 2 and Docker is you can use this handy script called install plugins, the SH, and just have all the plugins specified in code. So never again you need to click around and install. So on this line, I forgot to do soft wrap.
Soft wrap, yes.
On this page, but there's a fair amount of plugins that we are installing. Does someone have a question?
You were echoing.
Oh, I was echoing, sorry. So pipeline plugins, JUnit, Java specified here, Maven, 3, everything that we need, so we don't need to install anything by hand. And that, as well as like copying the static XML file over for Maven. So that's a Docker file. So what's cool about Docker is, so Vagrant's designed for developers. You should not run Vagrant anywhere else besides your machine. Docker is for everything. It's for your computer, it's for QA, it's for Jenkins, it's for production. And it's still new, so it's still being experimented with, and like the Docker for Mac just came out like a couple months ago. I think it's still in beta, so I'm running beta software on my computer right now. And so this is the Docker file that specifies the container that can run anywhere. But how do we manage this? This is like a VM for Vagrant. We have what's called the Docker compose file. So here,
GitHub. The Docker file.
Yeah.
Yeah.
This specifies a couple things. Just like Vagrant, it maps the ports from the machine from the guest to the host. Specifies the volume location, and the big thing is who here has spun up Jenkins 2? Anyone? Okay, so there's a big prompt beginning for like, what setup do you want? What plugins do you want? Do you want the recommended plugins? Do you want to specify all the plugins that you want? So we specify run setup wizard false because we're like, we're going to do all this ourselves. We just want to spin up Jenkins and have it ready to go. We don't want a whole GUI interface. We're very anti-GUI over here. And so that should be spun up. So I'm going to host 8080. So there, we have a fresh installation of Jenkins 2. The only thing on here are plugins that we specified in the installation list. So with Jenkins 2, it didn't start with Jenkins 2, but Jenkins 2 is sort of built around the pipeline plugin. And how the pipeline plugin works is you have a Jenkins file that specifies the entire plugin. Very similar to Groovy DSL. It uses Groovy syntax. Let's pull that up. It's pretty much always called the Jenkins file. So it's a little different than Groovy DSL. I'll make that a little bigger. Do the software wrap this time. So what Groovy DSL does is you are creating jobs. So you generate the same XML that you would with a GUI, versus the pipeline plugin doesn't generate jobs. It generates a plugin. So where Groovy DSL kind of generates what you already know, pipeline is something new. So instead of just generating a build job, it's just It's just part of the pipeline.
It's an interpreter.
Yeah, exactly. It's just interpreting the steps here. So even if you had 10 steps, you'd build, deploy, add tests. It's not going to have multiple jobs. It's just going to be a pipeline in this one job. So I'm going to throw this. This is the exact same thing that the Groovy DSL does. It's a little different syntax. So specify node. For every node in your pipeline is a workspace. So we're going to use the same workspace. It makes it easy to pull from multiple Git repos, which Jenkins does not do very well. Usually you want to do like one Git repo per job. Otherwise it gets kind of messy. So in this case, we're going to do one workspace. I decided to do 2 stages, which are just blocks. It's just like for, makes it look nice in the pipeline for checkout and build. And then I threw this in there, deploy to server. I can have a 3rd step. And we're going to check out from the same repo. And we're going to build it. Syntax is a little different, but we could do throw Groovy functions in here as well. Any questions about this?
Ben, so this is like one node is for one particular Git repo. So if I have like 10 different
for one workspace, like Jenkins workspace is just a directory where like things happen.
Right. So if I have suppose 10 projects, like 10 Git repos, so we'll have like 10 nodes, and we'll have a separate job for every repo.
Yeah, it's like a separate pipeline. Yeah.
Okay.
Okay. Yes, exactly. So I'm gonna grab this script. We're gonna do a new job. So right here. So it doesn't look very different right now, but everything changes. So instead of just doing a freestyle job, we're gonna do new pipeline. So let's just call it the same thing, job creator. And we're gonna throw this in line. And we're gonna save it, and we're gonna build it. So as that goes, normal Jenkins output. It's a little nicer. It's going to specify it's going to have 1 block per stage. And that's going to take just as long as that clinic is going to take to build. But I have to check that out, and then it's going to build, and then as that goes through. So advantages to DSL over pipeline. Does anyone guess what the major flaw is with pipeline? No, it's not testable because it doesn't generate anything that we can test with like what we know. You know what I mean? It's not generating XML. It's running steps. Versus Job DSL is testable, and that's I think a big thing that's stopping companies from moving towards Jenkins file. I mean, there are plenty of companies that are, and Jenkins 2 is pretty popular, but it's like most are still on Jenkins 1 because of that fact. So as that goes, there we go. So complete. So I didn't do anything, but I specified that there's a stage called deploy to server, so that's there. So in Nexus, it should be in the same location. It should be the 6th WAR that's been deployed to that location. Yeah, there it is. And to be clear, so Nexus, this is a vanilla installation of Nexus. I pulled it down from a public repo and just did Docker compose up.
I'll switch to the slide deck.
Sure.
So very high level, very simple. We didn't get into the specifics. Now you can, for any administrators that are out there, or anybody who wants to use it, couple of talking points, I guess. If you have Scrum Masters, if you have managers, if you have Agile coaches, if you have testers who don't go into Jenkins, all that, if this is how easy it becomes. Go to the pipeline slide. This is how easy it becomes for everybody to start using the tool. Where the industry is again going as everything as a service, right? You can talk about this as pipeline as a service as well, right? How do you change behaviors in your organization to be able to say it's no longer a push model, it's more of a pull model? Don't be afraid of the tools, right? Go use them. Jenkins is not something that a build and a deployment team should only be managing. Everybody should be using it. Testing teams more than anybody else, development teams a lot should be using it. Number two is think about how this can scale up. I know this is a very small example. Think about how this can scale up to manage everything in your pipeline, environments. Now, we could complicate this a little more and say it's no longer Docker Compose or it's no longer a Vagrant file. We can do all of this with Chef as well, right? Almost all of your configurations, and that you can reuse again and again. So how do you take this philosophy? How do you take this principle and apply it to environments? I'm sure a lot of places in your companies talk about environments are a problem, environments are down. But when you really dig into it, are environments really down? A service that a tester or a developer is working on is down. The way we talk about it in large enterprises is an environment is down. How can you move away from having those conversations to having conversations like everything is code? I can recreate environments again and again. Just like we showed you how Ben just destroyed his Vagrant box and he can spin up another one. You can apply the same principles to all parts of the pipeline. And that is where the value of all of this automation really lies. Number one. Number two, from a Jenkins administration standpoint, everybody can have multiple Jenkins instances. We're going into this master-slave model where all of the jobs are on master, but the execution actually happens on slaves. You can, if you're an administrator, if you're a platform engineer and you're moving data centers, or if you're trying to spin up new instances, this is how easy it becomes. More than anything else, the conversation, yeah, we started off with very small saying Jenkins, but then just apply this across the board to the entire pipeline, to the entire software development and delivery world. You can reuse the same principles again and again. And with that, that's our demo. That's our presentation.
So, question. So you can't do the Groovy script on Jenkins? You can't.
Oh, you can use it. You can use Groovy DSL. Exactly. Sorry, I may not be clear about that.
Yeah.
That's just the pipelines and like the way things are moving towards. But everything that you can run in Jenkins 1, you can run in Jenkins 2.
Okay.
And I use them interchangeably, honestly, locally. So I'm just running Jenkins 2, so I'm running Jenkins 1, but I am always, well, for now, doing Groovy DSL. So everything, so that is like the official supported, like that's what's built into Jenkins. You could even, not that many people know this, but you could go to your Jenkins URL and do /script, and you could run scripts directly on Jenkins, change things. Go ahead. Yeah. So alternatives to Groovy DSL, there are plugins, like I think you use a Python or a Node API, but those, I think they end up calling Groovy directly, so it's kind of redundant. Because you have to wait for someone else to add that feature to Python or Node.js. And even for Groovy, it's there's not a plugin that exists. Like there's not, like, if someone hasn't written a function to do something for your plugin, you can actually alter the XML directly with Groovy. It has like an API where you specify which XML blocks to alter, and you can alter them directly. And I do that for a couple of things. For some reason, the simple email plugin like that's built into Jenkins, there's no function to call that. So you have to call that the configure block.
Is there a way to generate the DSL from an existing configuration?
Not that I know of.
Oh, reverse engineer?
Yeah.
They're pretty cool.
Yeah.
But one thing that's nice is if you went to the time and wrote out the DSL to match your current configuration and you run the DSL, it won't change your configuration. It won't like delete them and recreate them. It'll just like it'll write on top of them and make any changes that you make, and then all of a sudden it's stored in source control.
Okay.
So it's not a huge. It's a nice transition as long as the names match. That's one thing you have to make sure. Anything else?
Any other questions before I get the demo? Is it good? Okay. Let me see if I can get my thing. No, actually, I'm gonna go through the screenshot.
Oh, I'll just switch to you.
Yeah, switch. Yeah. This is my work computer, so I brought some very ancient technology.
Yeah, that thing's a boat anchor. Did you hurt yourself carrying it over?
I have help.
Oh, okay.
That's what he uses to on Oakland downtown and San Francisco downtown. That's his weapon out there.
That's right.
Bring it at people.
It scares me every time.
Are you logged on?
Yeah, David. I saw.
Are you, this is you waiting for name?
Could be me.
You weren't kidding about not caring about
There you go.
security.
Yeah, that was his name. He was waiting for a name.
Okay, I never done this. Trying to add some extension. This will be interesting.
10-minute break.
Like, entire screen.
7th inning stretch.
Share entire screen. Okay, how's it going?
There it is.
All right. Okay.
The what? It's our alarm that goes every time. I'm just willing to unprogram it.
All right. So looks like it's working. So let me explain what I did. So because I'm not at liberty to share the wonderful work that we do at my company, I decided to hack something up. And the very nice people at DigitalOcean gave me some credits to play around with their cloud. So I appreciate that. And what I did is I created a simple, Linux box in DigitalOcean, and I created two Docker containers, one for the master and one for the slave. So let me show you basically where this ended up. So here's the master, and I'm doing all my work in the open. So if you guys want to go to github.com/Vidra, you can follow my work. What I intend to do is to continue hacking this, and if anyone wants to join me, please welcome, or you can fork my repo, etc. So look how simple it is. If you just want to do very simple Docker, you have a file called plugins text where you do need to figure out which plugin you need. This is the unfortunate thing about Jenkins, is that it doesn't automatically figure out the dependencies. So you kind of have to go read through. For the plugin that you need for Jenkins, you have to go read what it depends on, and you have to go reading kind of down the line. But you can see it's not that bad. The ones I needed, I just had to add a few of them. And then my Docker file is very simple. How about that, huh? So, so what I'm doing is I'm using the official Jenkins Docker file, right? So CloudBees have been very nice to publish their official, stable release Jenkins Docker file. And so all I have to do is to add these lines. So what does this actually do? So when you build a Docker image, right? So when you work with Docker, you have this idea of I'm building an image, which is kind of similar to like a virtual machine image in the old days, right? And then you run the image, right? When you run the image, you get a live container, right? But in the process of building the image, you can make it do stuff, and it will save the state of whatever you did in the image. So all you have to do is just copy this file from your local directory into the image, and then just execute this shell script. So this shell script was written by CloudBees, and it knows how to interpret the text file containing the plugin versions, and that's it. So as simple as that, right? You can automatically control which plugins are in your Jenkins and bring up the master. That's all I have to do. So in terms of how I actually did it, let's see, is this big enough? Oh, it's not going to be big enough, is it? Maybe it is. Okay. So just go into history and basically show you guys. So the first thing I did is I did Docker build, -t, and then you have to give your image a name. So I did that. So if I do Docker images, you can see that here's for example the image that I built, and then I just ran this no-hop Docker run command for testing. And the important thing here, there's two things to look at. A, I'm forwarding ports just like Ben was doing, right? So same concept as with the virtual machine running through Vagrant. You have an internal port, and then you have a port on your host and and you have to map them. So here I'm just doing very simple mapping because I don't need anything special. The second thing is that I'm mounting a value. So when my master runs, it is not writing all the information inside of the image. It actually has a mounted volume and everything goes there. So what that means is that if I go there, so if I go to my Jenkins home and I do, so you can see that all the files are there, right? And this survives the restarts of the Docker container. So if my Docker container dies for some reason, no problem, I just restart it, or I can have some kind of service that restarts it. All the data is just on a regular volume, and then I can use normal backup procedures to back up my data. So this isn't like a pure DevOps approach where everything is completely fresh every time I start something, but I think it's a reasonable compromise. It makes it easier to reason about what Docker does, and makes, if you're familiar with like running a regular Jenkins, it's almost the same, right? Because you have the same directory and everything is there. You can go look at it and change it. Right? Make sense? Any questions on that? How I got the master running? Okay. So the second thing that I did is I built Slave. Now, the idea is this: you don't really want to run jobs on the master, because especially in large enterprise, they have different kinds of teams. They use different kinds of technologies. So what you want to do is you want to build custom Docker agents or Docker slave images, which has exactly the tool chain that that particular team needs. And then they basically either control it, or there's some agreement as to how you evolve the tool chain, right? So for example, if your team is using Java 1.7.17, right, what you don't want is for somebody to rip it from under you and put something else in 3 hours before you go to release, right? What you want is you want stability of your tool chain, and you want to be in control when you promote to work through. So in order to do that, let me show you a simple example. I have here a Docker file, and this is a little bit more complex, but very similar to what Ben showed. I'm starting with Java 8 JDK. So this is like the official Java Docker image that it will download from the internet-based Docker Hub, and then you install into it. So I'm using Ubuntu. Whatever you need, right? So it's almost the same as just setting up your normal Linux workstation. You basically download. So let's say we need this particular version of Maven. So I download a particular version of Maven, set it up, and then I have my Jenkins slave jar installed. So when this image comes up, what it does is it tries to connect to the master and saying, "Hey, I'm available. Here, I'm an agent, I'm a slave ready to execute your work." That's basically how this works. There's one trick I did to speed up Java builds, is that I added a pom.xml file that contains dependencies that this particular team uses, and I did a Maven verify fail never. So what it did is that Maven basically downloaded all the dependencies into a local repo, right? The .env directory, and so now it's saved in the image. So now when this runs, it will be faster than if it was downloading everything from scratch every time. And at the end, basically, you just run the.
So that's sort of your poor man's artifact store. Is that what you're?
Well, no. This
is Maven.
This is
really for Maven. Okay.
Yeah, this is only for Maven, and this basically replicates what you do like on your local machine, where the first time you do Maven build can be very slow because it downloads all the artifacts, but the second time it's already cached. This kind of replicates that. Now, you may or may not need that approach, right? If, for example, you have local artifactory that is local to your build environment on a very fast network, you probably don't need it.
Yeah, that was kind of my question.
But you would still want it. I think in some companies, you want to make sure that they're using the right version of the library all the time.
Right.
So this is a good approach. Depends upon how you're using it. What we were trying to show more was the speed and the agility of it.
Sure.
This would be a very enterprise watching for all things, making sure there's standardization across all the things. That's how you do it.
Okay.
So, and this gets a little bit wonkier because you do have to hack a file, you have to replace password authentication, and then basically what we do is we have this extra script that sets up the password authentication, right? Basically passing a public key, and so when this agent runs, it has the public key, and it will connect to the server, authenticate, and become a Jenkins agent. Right? So let me show you how you configure it on the Jenkins side, and then I'll take some questions. So on the Jenkins side, you go into Manage Jenkins, and you go to Configure System. And then you find this very popular word called cloud. If you got cloud, you must be like Muslim, right? And then you configure your Docker, right? So you give it a name, it's called local Docker. You give it the AP of the Docker daemon, right? So when you install Docker, there's a Docker daemon that runs and listens for commands. So it just runs on the same machine as everything else. And then you create as many Docker templates as you want, right? So essentially for each kind of agent image that you've prepared, you create a Docker template here, right? So this is all part of the Docker plugin that I installed into the master. So you give it a name, right? So this is the name of the image that I built, the Docker image, and then you give it a label. This is important. So what happens is that when you define a job in Jenkins, there's a section where you're going to restrict where the job can run, and then you give it a label, and so when the job runs, it will spin up this particular Docker image that pretty much specifically belongs to your team, and then all your builds will be very consistent, right? So it will always basically start with a completely fresh environment that you completely control. Right. And then, yes, we're using SSH, and the trick is, here's the trick. I can find the trick. I need to find it. See if I find the trick. It's one of these. Container set. Yes, there's the trick. So the trick is that you have an agreed upon environmental variable where you pass the public key, right? So in Jenkins, I set up credentials. So I set up credentials, and I created credentials. I think, yeah, this guy, right? So there's a private key. And the public key I'm passing through this environmental variable to the container running the slave, then it talks back to the master and connects like that. Okay? Any questions?
Where do you get the key from?
Oh, I just created the key. I just did the SSH key gen on my machine and just pasted it. Yeah, you can just paste the key into Jenkins, right? So the key's there. Now, again, if I was a real professional, I would script everything, but this is as far as I got for my personal job. But as you can see, most of it is scripted, and it's very easy to set up. Especially what I wanted to convey is that even for smallish projects, right, where you don't have like a DevOps team, right, you don't have professionals you can bring in house. This really is not that difficult to do, right? Like even as a manager, even I can. Come on, how hard can it be? So given that, let's see if this actually works. And I've tested this a bunch of times, as you can see, like 20 times, but you never know, it's live demo, right? So I'll kick this off, and you can see it's waiting. So let's go see what's going on here on this side. So if I do DPS, there we go. There's the master running, right? And there's the agent that it just started, right? And so, oh, here we go, look at that. It's running, and it's running our build, and all right, live demo. So that's pretty much what I have, and again, I'll continue playing with this, and if anybody's interested, go to my GitHub and do pull requests or whatever you guys want. There it goes, it's finished. So yeah, very nice and really not that difficult, and obviously this will work with JobDSL as well. Now I want to spend a few minutes and talk about the Jenkins file. Sorry, right? Well, the pipeline. Okay. So here's a very simple pipeline that I created that does absolutely nothing. So it runs really, really fast. I really like those. I'm addicted to speed. I just love when it runs really fast. But here's the interesting thing. The architecture around the Jenkins pipeline is very interesting. It's using something called Groovy CPS. Groovy CPS stands for Groovy Continuation Passing Style. Has anybody worked with a language that supports continuation? basically the idea behind continuations is that you can actually freeze the execution of your program, basically write the stack somewhere, and then restart and continue with the execution. So what's nice about that? This approach survives Jenkins master failures. The Jenkins master may die, you bring it back up, it will continue running the pipeline because it writes everything to disks for each step. What else is interesting is that if we look at a particular run,
But how? We'll ask the questions later. Sorry.
no problem, yeah. Let me show this. You can see that it broke my pipeline into all these multiple steps, and each step has its own log, right? How cool is that, right? When you have complex pipelines, you can go look at the log fragments just for that, right? So you can see what it did, broke it out, and ran each thing in a separate context, and wrote everything to disk for each step, right? Let me just show you, I forgot to show you how it looks. It's really trivial. Again, typically you would store these in something called Jenkins file, you put it into your project repo, right? That's the whole idea of pipeline as code. But here again, just for simplicity, I just pasted it in, and it's just a bunch of stages that doesn't do anything. I was working on getting it actually running in the Docker slave, but I ran out of time. So very, very trivial. So I think this technology has some future. I agree it's still more experimental at this point, but it's very promising, and I do like you know, this idea where you can go and look at the individual steps and examine them, and you can see the status for each step. And I think that's very nice. Go ahead.
So CPS?
Continuation test. The GUI CPS is the library they use.
Okay. Cool.
Yeah, very cool.
What is the use case for continuation? I mean, I know you said Jenkins master fails. So I'm just trying to think, is it used for regression tests? If you want to run multi-day regression tests, should we use this for that?
No, so what I mean by continuations is this. Let me open this in a separate browser.
So when Jenkins restarts for some reason in the middle of a job, so I can like restart.
Yeah. Basically, what I mean by continuation is this script here looks like a normal script, right?
Mm-hmm.
And so typically in any scripting language, you'd imagine that this thing would just be executing along and execute, right? Well, actually, that's not how it works. Under the covers, it actually breaks it up into a bunch of little scripts and runs each one separately and runs the results of each one to disk and knows exactly where it's at. So if the whole thing dies and then you restart, it says, oh, okay, I went through like these stages, but not the last stage. We'll just continue running the last stage, right? Which is very, very cool, and that's what you want for kind of enterprise-grade behavior, right? So I'm mildly optimistic on this technology. We're not running in production, so I cannot, I'm not going to swear on things that I haven't used for 6 months. But technically, it's interesting. The idea that's interesting is that all of these, commands are using, they're called steps, and you can write your own steps. So if you're a Java developer, you can write your own steps in Java and then basically package them as a plugin, upload them to your master, and so you can extend the language.
So if I write a wait for testing step for, let's say, 3 hours only because it's a large data file that's going through some validation, will the executor be taken up for that wait, or will it?
Ooh, tricky question. I don't know the answer, probably, but again, if you think about it, when you're using slave-little Docker containers, they're not that expensive.
Yeah, fair. That's a fair point.
You can control how many Docker containers you're going to run, and you can balance. I think in general, developer time is the most expensive. I mean, imagine somebody manually editing those 800 jobs. Right? I'm not going to ask for group confessions here, but been there, done that, right? Not very pleasant. So getting all this automated really is the key, and then you can move faster, you can experiment faster. I mean, I cannot tell you, basically this has saved us because we had projects where we were writing some new tools, we were changing the command line options in these new deployment tools we were writing, and being able to go and just run a simple job that like recreated those 300 Jenkins jobs in like 3 seconds was really what allowed us to experiment with new tooling and to quickly evolve our jobs, right? If we didn't have that, we couldn't even attempt to do that. Right? That just would not happen, right? So it really was a game changer for us. All right. Any other questions? Is there enough information for one meetup, or should we get?
What do you think?
Great.
Yeah?
Yeah.
Oh, we finished at 7:30, so we have 30 minutes for questions.
Great. Thanks everybody for coming. Yeah, and if you have any questions or anything, I have.
So I haven't had any meetups in Pleasanton. I usually San Francisco or Valley. How many times it happened like here in Pleasanton?
This is my first as well, here in Pleasanton.
Yeah?
So
Once a month. We meet up here once a month.
Yeah?
Mm-hmm.
Oh.
Yeah. It varies from, just agile, QA, development, sometimes on management. We like to touch a little bit of everything. But we'll have one in December since we had 2 this month. But we'll start up next year and it'll be once a month. Yeah. Awesome. Well, Ben, Ravi, David, thank you. That was great. And I thank you guys for attending. Meetups are only possible if people show up. So thanks, guys.
yeah, thanks a lot. And shameless spiel, here are some of our cards. Looking for jobs, please let us know. Reach out to us if you have questions. Anonymous feedback.